All right, here we go, beginning our Unit D, our fourth unit of the school year, beginning with objectives 20 and 21. Now, objectives 20 and 21 talks about determining functions from graphs and tables. So first I want to talk about what a function is and then how we can determine it from a graph and how we can determine it from a table. So let's first start by defining what is a function. A function is a special relation that takes each input and pairs it with a unique output. So a function is a special relation that takes each input and pairs it with a unique output. So I like to think functions as like machines, right? So machines, you'll plug in, you'll put something into the machine, it'll do its work, and then it'll spit something back out. So we draw in our machine, and we'll specifically call this one f. So our function f. Any machine takes an input and it goes into the machine, into the function, and it spits out an output. So if we were to call this in mathematical terms, we would say like our inputs would be like our x values. And if it's a function, then our outputs would be like our y values. Now, in order to determine whether or not these are functions, we know that each x can only have one y. And that's where we get that from the definition. It pairs it with a unique output. So for every x that you put in, it spits out a unique y, or it only has one y value. Okay. One way that we can determine this from graphs is by using the vertical line test. So the vertical line test, as a reminder, vertical lines go up and down. We can use the vertical line test by determining if any vertical line intersects your graph more than once. So if it intersects your graph more than once, it is not a function. So the vertical line test, if any vertical line intersects your graph more than once, it is not a function. So let's take a look at a few examples. This first one, if I were to draw in vertical lines, we see that these vertical lines only intersect the graph once each. It intersects here, here, here. Each of these lines only intersect the graph once. Let's take a look at another example. We can draw in our vertical lines. So it doesn't matter how close you put them, as long as each vertical line only intersects the graph once, then it's a function. Right? We can do that for this one here. You can draw on your vertical lines. This only intersects the graph once. Oh, and let's write this in. So, of course, this first one is a function, only intersects once per line. This one is also a function, only intersects once per line. This third one is also a function. This fourth one, again, we can draw in our vertical lines. They only intersect the function once each. So this is a function. They only intersect the graph once each. Now, if I were to take a look at this next one, this one we've got like this X shape. If I were to draw in a vertical line here, notice that it crosses the graph in two places. So this here is not a function. Now, some of you might be looking at this and say, well, what if you draw a vertical line right down the middle? It would only cross the graph once. And that's correct. It would only cross the graph once. But the vertical line test says if any vertical line, so you can draw a vertical line anywhere, if any one of them intersects your graph more than once, then it's not a function. So even though this does have one vertical line that works, any other vertical line would not. And likewise for this one, I can draw in a vertical line here and see how it crosses the graph twice. This is not a function. Let's take a look at determining functions from tables of values. Go ahead and flip the page. So here I want to talk about how we can determine functions from tables of values. So determining functions from tables of values. And what I mean by that is determining whether or not something is a function from the table of values. So here we consider three cases. Case one is if all x's are different, then yes, it is a function. So if all x's are different, then yes, it's a function. Case two, if you have the same x and it's paired with the same y, then yes, it's a function. It's a function. If you have the same x and it's paired with the same y, then yes, it's a function. And last but not least, case three, if you have the same x and it's paired with different y's, then no, it's not a function. If you have the same x and it's paired with different y's, then no, it's not a function. So let's take a look at some of these tables of values and determine whether or not they are functions. So here I'm looking at the x's. We have -2, 1, 6, 7, 9. These are all different, so this is case one. Yes, this is a function. And for an explanation, we can say all different x's. This next one, we have -2, -1, 0, 1, 2. Yeah, these are all different. So yes, again, the same reason, all different x's. Next up, we've got this one. We've got -3, -1, 1, 1, 4. Well, I see two that are the same. So now we have to look at the y's, or the f of x. So these are both, our y values are 0. So because these are the same, we're looking at case two. So yes, this is a function. And for the explanation, we can say same x has the same y. So even though these are the same x, they have the same y. So this is a function. Next, we have 1, 2, 3, 4, 4. Well, these two are the same. When we look at the y values, this is 6 and 7. These are different y values. So no, this is not a function. This is case three. Same x's have different y's. All right, next up we've got -8, -3, 0, 2, 5. These are all different x's. So yes, this is case one. All different x's. Next one, we've got 0, 5, 9, -2, -4. So again, case one, yes, this is a function, all different x's. Two more, we've got 0, 5, 9, -2, 0. Oh, I see two zeros, so now we got to look at the y's. Well, the y values are different, so this is case three. No, this is not a function. The same x's have different y's. And last but not least, -5, -3, 0, 3, and 7. Again, all of these x's are different. So yes, this is a function, all different x's. All right. So this is objectives 20 and 21, which is functions and determining them from graphs and tables of values. We're going to get a whole lot of practice of this in class. So study up and we'll see you tomorrow. Have a great day.